quick review of polar functions today and polar coordinates. So we know that polar coordinates are composed of the radius and the angle in your equation. Okay, so I always go to the angle first. So I'm going to go to 5 pi over 3. So it's going to be 5 pi over 3. Okay, in the fourth quadrant, and then I need to go out 1, 2, 3, 4 units. 1, 2, 3, 4 units. So our point A would be, point P. Let me right here. Okay. The next coordinate is 3 comma 7 pi over 6. So again, I like to go to the angle first. So 7 pi over 6 is in the third quadrant, and then I'm going to move out 1, 2, 3 units. So I have point Q. Okay, point R, we're going to go to 5 pi over 4, which is also in the fourth quadrant. So it'd be right here in between 7 pi over 6 and 4 pi over 3, which is 5 pi over 4. And then because it's a negative radius, we walk backwards. So I go back 1, 2 units. So remember, this point can be rewritten as the radius of 2 and an angle of pi over 4 if you want. Okay. So facing pi over 4 and then walking forward. All right. We have point S is 1 comma negative pi over 3. So I'm going to go negative pi over 3, which is negative 60. Okay. And then I'm going to walk 1 unit forward. So I end up right here at S. Another way we could write this, this point is with a positive coterminal angle. I'm going to add 2 pi. So that gives me negative pi over 3 plus 2 pi. So that's 6 over 3 pi, which gives me 5 pi over 3. Okay. Oh, it says right here, 5 pi over 3. All right. So in pre-calculus, we learned that the cosine, so if I draw my little angle here in the first quadrant, we end up with the angle theta. I have a y length, an x length, and an r length. I know that r is equal to the square root of x squared plus y squared. Y is equal to the radius times sine theta, and x is equal to the radius times cosine theta. So, and this is the point x comma y. So I know that cosine theta is equal to the x over the r length, which then if I solve for x is r cosine theta. I know sine is y over r, so if I solve for y, that would be r sine theta. Tangent theta is equal to y over x. So we can say theta is equal to tan inverse of y over x plus pi n. Okay. And x squared plus y squared is equal to r squared. So the r is equal to the square root of x squared plus y squared. Okay, so that's like our toolkit, and we use that to convert back and forth between polar and rectangular equations. So we are going to convert 2 comma 5 pi over 6 to a rectangular coordinate, which means x comma y coordinate. So the 2 represents our r, and the 5 pi over 6 represents our x. I know that x comma y can be rewritten as, from our toolkit, remember, we have x is equal to r times cosine theta, and y is r times sine theta. So we just need to evaluate that now. So I'm going to do x is equal to r times the cosine of theta, which r is equal to 2, and theta is equal to 5 pi over 6. I'm going to do the same thing for y, so but with sine. So I have 2 sine of 5 pi over 6. I like to draw my triangle. It's actually in the second quadrant, so 5 pi over 6. So over 6 has a vertical length of 1/2 and then negative root 3 over 2 since we're in the second quadrant and a radius of 1. So I'm going to end up with 2. Cosine would be root 3 over 2. So this negative root 3 over 2. So this reduces to negative root 3. And then for the y, 2 times sine of 5 pi over 6 is 2 times 1/2, which is just 1. So that means that our point written in rectangular form would be x is negative root 3 and our y is 1. Okay, so now let's go ahead and convert to polar form. So that means that I started with an x and a y, and what we want to change to is our point in terms of r and theta. R comma theta is equal to, and so what I need to do is, actually, let's chill there. Okay, I have x and y, so I'm looking like, okay, so 3, positive 1, 2, 3, negative 1, 2, 3. I have a vector that looks like this. So I want to, with x is equal to 3 and my y is equal to negative 3. Okay, so now we need to take these x and the y and figure out how can I convert this to give me r and theta. So luckily, I have my equations here where I have my x and y and I want to know my r, so I can use this x squared plus y squared equals r squared to solve for r. And then we can use the tangent of theta because I want to get theta and I have x and y, so I can solve for theta by putting in the ratio. Okay, so we need two pieces of information here. X squared plus y squared is equal to r squared. So I get 3 squared plus negative 3 squared is equal to r squared. So 9 plus 9 equals r squared. So I'm going to have r squared is equal to 18. Take the square root, and that's 9 times 2, so 3 root 2 is my r. So r is equal to 3 root 2. Okay, we're halfway there. Now we need theta. So I'm going to use the equation tangent theta is equal to y over x. Replace y over x with negative 3 over 3, which is negative 1. So, that's bad. Tan inverse of negative 1 is equal to theta. I really have it set up in my picture over here, so I can see that if I use a calculator, it's going to give me the negative angle. So I'm going to say theta is equal to negative pi over 4. Okay, so theta is equal to negative pi over 4 plus pi n, because it is an inverse tangent equation. So again, there's multiple angles that will fulfill this equation. Okay, so, but it's every 360 degrees, so we're going to say 2 pi n, because the secondary angle, you'd have to reverse the radius. Okay, so I'd have my polar coordinate r comma theta is equal to 3 root 2 comma negative pi over 4, or an equivalent version is 3 root 2 comma 7 pi over 4. All right, next we need to convert the following equations to polar form. So again, in terms of r and theta, so we need to use our toolkit. I know that y equals 4, and I have this equation y is equal to r sine theta. We like this because the equation here on the right-hand side has r and theta in it, which is what we need to convert to polar form. So I'm just going to replace the y with 4. So 4 is equal to r sine theta. And then I'm going to isolate r. So r is equal to 4 divided by sine theta. And we're done. Okay, next one. X squared plus y squared is equal to r squared. So I again have this equation x squared plus y squared, is equal to 25. But I have the equation x squared plus y squared is equal to r squared. So I'm going to replace my x squared plus y squared with 25 because I want to write my equations in terms of r. So we need to leave r. Okay. Then I'm going to take the square root. R is equal to plus or minus 5. I'm just going to put plus 5 because a positive 5 radius and a negative 5 radius will graph the same thing. Okay. We're going to convert, excuse me, the following equation to rectangular form and then sketch. So rectangular form means in terms of x and y, okay? And then, so I have r sine theta is equal to 3, and then we need to use our toolkit. So I know that y is equal to r sine theta. So I can just replace the r sine theta with 3. So y is equal to 3. And y is equal to 3 looks like a horizontal line. Okay. Next one, r is equal to 2 cosine theta. This is close to what we know. We have x is equal to r cosine theta, but the r is missing here. So we're just going to multiply both sides by r. We get r squared is equal to 2r cosine theta. And then I can replace this r cosine theta with x, and we can replace r squared. So I know that, it's right here. X is equal to r cosine theta, and then r squared is equal to x squared plus y squared. So I can replace my, r squared with x squared plus y squared. And I can replace my r cosine theta with x. Okay. So I get x squared plus y squared is equal to 2x. Now we just need to, actually, I'm going to get everything to one side because this is x squared minus 2x plus y squared is equal to 0. And I did this because I can recognize this is a circle. So I'm going to complete the square. Negative 2 divided by 2 is negative 1 squared gives me 1. So I'm going to add 1 and add 1 to the right hand side. So this factors to x minus 1 squared plus y squared is equal to 1. So same stretch values. So this is a circle and with a center of 1, 0 and a radius equal to 1. So I have a center at 1, 0 and then a radius equal to 1. Okay. Last one. Theta is equal to 2x. So I start with my tangent theta is equal to y over x, since I have like theta in the equation, and really this is the only equation conversion that has theta in it. Okay, so I'm just going to evaluate the tangent of 2 pi over 3 is equal to y over x. The tangent of 2 pi over 3 means that the inside, the vertical length is longer, so root 3 over 2 over negative 1/2. When I divide those, I get negative root 3 is equal to y over x. Now we just need to isolate y. So I get negative root 3 times x. So what I see is that an equation written in polar form as theta equals is just it's just a line that goes through 0, 0. Okay, so I'm going to have my y-intercept at 0, 0. Negative root 3 is like less than 2. So I'm going to less than negative 2, or it's a little greater than negative 2. There we go. So I'm going to go up almost 2 and to the left 1, down almost 2 into the right one. This is a sketch. Okay. And my line goes through the pole like this, or it goes through 0, 0. Okay, that's it for our equations